Welcome to the NUPOC Video Study Guide number 12. Let's look at question 9 in the General Math section of Guide 1. This question is just asking us to convert 9,435 in base 10 into base 8. So any number expressed in any base, including in base 10, we're essentially expressing each of these numbers is really just a coefficient on the base raised to a certain power. So in base 10, let's look at what this number would be. So this would actually be equal to 5 times, let's see, 10 to the 0, right? Because this is the ones column. Anything to the 0 is 1. And so we always start with 0, the base to the 0 power, base to the first power, base to the second power, base to the third power, etc. And these numbers here are just the coefficients. So this is just 5 times 10 to the 0 plus 3 times 10 to the first, which is just 10, plus 4 times 10 to the second, right? 4 times 100, 400, plus 9 times 10 to the third. So that's what it is in base 10. So in base 8, or in any other base, all we're doing is we're just changing the base number here. But these powers will remain the same. And what we're looking for in this problem is what these coefficients are. So I'm just going to write what this equals. This is 9,435. So in base 8, I'm going to write this in reverse. I'm going to go from the highest order term down to the lowest order term. So we're sort of writing it as we would write it. See here, we're backwards 5349 instead of 9435. But regardless, it's still this side of the equation is still equal to this side of the equation over here. Okay, so let's write out what we would have in base 8. Now we don't know how high we're going to have to go as far as the order of the base. We don't immediately know how high we're going to have to go, but we know that it's probably going to be maybe it's going to have to be higher, because we know base 8, right? 8 is less than 10, so we know we're going to have a bigger number than 9,435. And so we're going to, if we need more, 8 isn't that much less, so we might need one more term with a higher order on the base. Let's add 2 more and just see if we need it. Okay, so we're going to go up to the 5th power of our base, so 8 to the 5th. So we'll start with 8 to the 5th, and I'm going to leave a blank in front of each of these coefficients, and then we'll have 8 to the 4th, plus something 8 to the 3rd, plus something 8 to the 2nd, plus something 8 to the 1st, plus something 8 to the 0. And this is going to equal, the coefficients will just equal our number over here. So our number is 9,435, and we know we can start here, and we know what this number is, right? So this is 1, this is 8, this is 64, this is 512, this is 4096, and this is 32,768. And of course that's in base 10. So we don't need anything times 32,768 base 10 to come up with 9,435. So I'm going to write out, I'm going to call this C0, C1, C2, C3, C4, and C5. These are the coefficients we're looking for. So C5 can just be 0, because there's no integer multiple of 32,768 that is going to give us anything near 9,435. Now 8 to the 4th, that's only 4,096. So how many times, how many 4,096s can we fit into 9,435? Well, 4096 times 2 is going to be a little bit over 8,000. It's going to be right around, I think it's going to be, what, 8,192, I think. So that fits in here in 9435. So C2, or C4, excuse me, is going to equal 2. And then what do we have left over? Let's see. So it's going to be, we have 9435 minus 2 times 4096, right? So we have 1243 left over. 8 to the third is 512. How many times can 512 go into 1243? Probably about 2. So we're going to say C3 equals 2, right? And then after that, we have 1243 minus 2 times 512, which is 1024. We're left with 219. And we know 8 squared is 64. How many times can 64 go into 219? Well, 64 times 3 is going to be 180 plus 12, so that would be 192, so 3. So C2 equals 3. And we're left with 219 minus 192, which is going to give us 27. How many times does 27, or how many times does 8 to the first go into 27? How many of them can we fit? Well, probably about 3, because that'll give us 24. So C1 will equal 3. And of course, then we have 27 minus 24, which is obviously 3. So we're left over with this 8 to the 0 is just 1. How many times does 1 go into 3? The answer is 3. So the answer then is 2, 2, 3, 3, 3, base 8. Right? So if we went and we said, okay, 2 times 8 to the fourth plus 2 times 8 to the third plus 3 times 8 squared plus 3 times 8 plus 3, okay, if we did out that math in base 10, we would get 9435. But if we find these coefficients in base 8, it's 223333. So these coefficients give us our base 8 number. And you can do the same thing with any base. This is the representation of how you represent a number in any base. It's coefficients times that base raised to a certain power. That's how we do in base 10, base 2, base 8, whatever. And then the number is just stringing those coefficients together. So just to summarize, we'll say 9435 base 10 equals 2, 2, 3, 3, 3 base 8.